Let's dive into processing Extensible Markup Language, or XML, using Go. This video will help you master XML encoding and decoding using Go's powerful encoding/XML package. We'll be covering XML marshaling and unmarshaling, how to use struct tags and attributes, and some advanced XML handling techniques. So what exactly is XML? XML, which stands for Extensible Markup Language, is a markup language used for storing and transporting structured data. It's designed to be both human-readable and machine-readable. XML offers several key features. It is a human-readable format, making it easy to understand and edit. It provides self-describing data, meaning the structure and content are defined within the document itself. And it is platform-independent, allowing it to be used across different systems and applications. Here is an example. The person element contains name, age, and email elements. The name element contains the content John Doe, the age element contains the content 30, and the email element contains john@example.com. Go's standard library provides excellent support for XML processing through the Encoding/XML package. To use it, you need to import it into your Go program using the statement import encoding/XML. This package offers several key functions for encoding and decoding XML data. The Marshal function is used to encode Go data structures into XML. The Unmarshal function decodes XML data into Go data structures. The new encoder function creates a stream encoder for writing XML data. The new decoder function creates a stream decoder for reading XML data. To work with XML in Go, you'll typically define structs that represent the structure of your XML data. Here's a basic example. We define a type called person as a struct. The struct has three fields: name of type string, age of type integer, and email of type string. When defining structs for XML processing, remember that field names must be exported, meaning they must start with a capital letter. This allows the Encoding/XML package to access and manipulate these fields. Each field in a struct maps directly to XML elements. This is a simple struct without any XML tags. We'll see how to use tags to customize the mapping later. Let's look at an example of how to marshal or encode a Go struct into XML. First, we create an instance of the person struct, setting the name to Alice, age to 25, and email to alice@example.com. Then, we use the XML Marshal function to encode the struct into XML data. If there's an error during the marshaling process, we log the error and exit. The XML output is as follows. The person element contains a name element with the content Alice, an age element with the content 25, and an email element with the content alice@example.com. XML Struct Tags provide a powerful way to customize how Go structs are mapped to XML elements and attributes. Here's an example. We define a type called user as a struct. The struct has four fields: ID of type integer, full name of type string, age of type integer, and password of type string. Each field has a tag. The ID field has the tag XML equals ID attr, indicating that it should be mapped to the ID attribute in the XML. The full name field has the tag XML equals name, indicating that it should be mapped to the name element in the XML. The age field has the tag XML equals age, indicating that it should be mapped to the age element in the XML. The password field has the tag XML equals minus, which means skip the field. Here are some commonly used tag options. You can specify a custom element name using the name option. You can map a field to an XML attribute using the _attr option. You can skip a field using the hyphen option. And you can include raw XML content using the _inner XML option. Now let's see how to unmarshal or decode XML data into a Go struct. First, we have an XML input string containing a user element with an ID attribute set to 123, a name element with the content Bob, and an age element with the content 28. Next, we declare a variable u of type user. We then use the XML Unmarshal function to decode the XML data into the uStruct. If there's an error during the unmarshaling process, we log the error and exit. Finally, we print the contents of the uStruct using fmt printf with the +v verb to display the field names and values. For advanced XML processing, Go offers streaming capabilities that are particularly useful for handling large XML files. The XML new encoder function allows you to stream write XML data. The XML new decoder function allows you to stream read XML data. The token function allows you to parse XML data by tokens, giving you fine-grained control over the parsing process. Streaming is memory efficient for large files, as it processes the XML data in chunks rather than loading the entire file into memory at once. Here are some best practices to keep in mind. Always handle errors properly to ensure your code is robust and reliable. Use struct tags for custom mapping to precisely control how XML data is mapped to your Go structs. Validate XML input data to prevent security vulnerabilities and ensure data integrity. Use streaming for large files to minimize memory consumption and improve performance.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.